Hello. This is my first time in Chicago. I really like it. I'm here to talk about making AI voice agents sound like humans. Just a little bit about me. My name's Lily. I'm the CEO and one of the co-founders of Rime. We're based in San Francisco. Prior to founding the company, I was a PhD student at Stanford in the linguistics department working on voice AI research. And I'll give a bit of background about why we started the company and what we do in a second. But first, I just wanted to talk about the history of voice AI. I think it's very relevant in 2025 to think about how we got here. So where did the AI agentic hype cycle start? Probably back in the 12th century. Okay, I'm just going to read. This is from Wikipedia, apologies. I don't know if any of you have heard of the brazen head before, but this is sort of a meme throughout continental Europe in the 12th century. Okay, I'm quoting here. The first account of a talking head used to give its owner's answers to his questions appears in William of Malmesbury's circa 1125 History of the English Kings, in a passage where he collects various rumors surrounding the polymath Pope Sylvester II, who is said to have traveled to Al-Andalus and stolen a tome of secret knowledge, whose owner he was only able to escape through demonic assistance. He was said to have cast the head of a statue using his knowledge of astrology. It would not speak until spoken to, but then it answered any yes/no question put to it. So we have magic, astrology, some sort of connection with Catholic, I don't know, it's almost paganism, I guess, and also the Arabic Orient. And what do we get? We get something that's way worse than Siri, something that can answer any yes/no question put to it. Okay, moving forward though, right, if we're thinking about the actual technical beginnings of speech synthesis, by the way, that brazen head is mentioned very prominently in the history of speech synthesis literature. The actual technical beginnings of speech synthesis probably began in the 18th century, right? There were these things called organs, keyboard organs, and people had this idea, right? Like, if we can control the timbre of a fundamental frequency, right, that it's generated by some kind of reed and powered by some kind of bellow, and we do things that closely approximate the way that our vocal tract shapes that fundamental, then what we're going to get is something that sounds like speech. If any of you are aware of the history of phonetics, this is sort of like the very proto-beginning of the source filter theory. It took us by the way, 200 years to get anything closely resembling what a modern speech synthesis technology looks like. And at that point, right, we're not talking about just a couple sounds that sound like human speech. We're talking about like 12 and concatenated in really unnatural ways. Again, I'm from San Francisco. I think very relevant to think about when this started to have a business impact. I don't know if any of you have been on the BART subway system in the Bay Area. There used to be, I'm sad to report that they're no longer playing on the platform, but Bell Labs, back in 1996, put together some text-to-speech voices for BART, the Bay Area Rapid Transit System. And at that point, this is from a news article in 2006 that's sort of explaining the origins of these train announcement TTS voices that were put together by Bell Labs. They basically had to say, okay, here's why we're doing this. Why are we doing this? Because a human can't read all these announcements. In some stations with multiple train lines coming through, there may only be 1 second between each of the announcements. Again, I don't, to be honest, I don't know a lot about the history of IVR in contact centers. I think there's some world in which this isn't predating IVR, but at the same time, like one of the most consumer-focused, consumer-facing applications of text-to-speech. So if any of you haven't heard this before, I'm going to try to play sound now.
Hi, this is George. Welcome to BART's DSS audio service. My partner, Gracie, and I are the synthesized voices you hear while waiting for your train.
We only announce ETAs, train arrivals, and tell you when the train is boarding.
Here are some typical announcements. 10-car San Francisco Millbrae train in 8 minutes.
6-car Richmond train now approaching platform 1.
3-car Fremont train now boarding platform 2.
George, it's time to get back to work.
You're right as usual, Gracie. Goodbye and thanks for visiting. Say goodbye, Gracie.
Goodbye, Gracie.
Got some humor at the end there. I would say, right, like not only are these voices robotic, they're actively hard to understand at some points. So where are we in 2025? I mean, I think it's again, like I want to reiterate, it took us 600, 700 years for us to get from something that was myth to something that closely approximated the shape of technology moving forward. It took us another 200 years to get something that could generate what you just heard. And then in another 30 years, what do we get? We get the ability to spin up a demo using 3 APIs, speech recognition, some kind of LLM, and a text-to-speech system. And if you go to I should put the URL on here, but if you go to www.rime.ai/try, we can do this trivial. I mean, it's absolutely insane how trivial this is at this point. We have folks who are coming to this page, talking to our healthcare demo, and then talking for another 30 minutes with a bot just about anything other than healthcare, right? But we prototypically have been selling to contact centers, and so you can imagine here like some of the top 4 use cases. Again, does this do anything? Namely, does it make function calls to the POS system for the food ordering use case? No, it does not. Does it make connection with the CRM and some sort of appointment scheduling functionality for the healthcare demo? No, it doesn't. It's just really fun to talk to. So why did we start Rime? I have to admit, when I started the company in 2022, 2023, I didn't know anything about enterprise telephony. I didn't know the acronym IVR. I didn't know what call containment meant. I didn't know what CSAT or NPS meant. But we started because I could tell, right, like the way that Google, Microsoft, and Amazon treat these models is as commodity products. And to put it in another set of words, right? Like when I call Verizon, I shouldn't want to kill myself. Very simply, like as someone who cares very deeply about language and about what language means to humans, I just knew it didn't have to be that way. We've built a pretty small team at this point. We, of course, like we're a venture-backed startup. We're something like 12 full-time employees at this point. And where has that gotten us over the last 2 years? Well, I have to say I know what IVR means now. And we're now powering tens of millions of calls every month for brands like Verizon, Amazon, Domino's. We're at the drive-thru in Carl's Jr. And powering a lot of outbound lead qualification calling for some of these real estate companies. And then many other use cases in healthcare, in retail, et cetera, and customer support. And I think that's pretty remarkable that a team of 10 can, in many of these cases, like folks are switching from a hyperscaler text-to-speech API and running a pilot where they're comparing some kind of KPI, like order success in the fast food ordering use case, and finding that Rime is outperforming Microsoft, for example, right? Like when the phone, okay, it's not Domino's themselves. As you can imagine, like selling to Domino's is like probably pretty hard, but individual franchises, when they switch from Microsoft TTS voices to Rime TTS voices, what they're finding is that 15% of callers who otherwise were not completing that order now complete the order. And put another way, like 15% of, it represents a 15% increase in the likelihood of just finishing an order. And so at the end of the day, right, like what does a more human voice AI experience do? It has business impact, which I think is obvious if you've called some of these systems in the last 30 years, right? Like I see at the end of the day what the goal of what we provide to our customers is just very simply increasing the willingness to talk to the bot. Right? Like it simply does not matter if the LLM has the ability to make the relevant function calls, if it can do things that you were never able to do with Google Dialogflow, if the customer hangs up after hearing the first thing the bot says. So what does a call sound like? It sounds like this. This is kind of what I think of as like 90% of the way there to something that approximates a human conversation. Something that's pretty interesting about this is that the customer who built this, they're calling it a conversational IVR. What they find is Now they're testing something like 30 or 40 different voices in production, and then finding which voice results in the best increase in KPIs that are relevant to them. And I often find that it's not the voices you would expect. So again, this is a IVR system for customer support for a large telco. What do they find? They find that this voice in particular outperforms all other voices in increasing CSAT.
Before we go ahead and connect you with someone, I just need to grab a bit of basic info. It's really just so we can make sure we match you with the best person to help out. So, to start, could I get your first and last name?
Yeah, it's John.
Thanks, John. Could you please share the phone number associated with your account?
Yeah, it's 206-339.
So, what brings you to call today? Is there an issue you're experiencing with your device or account?
Pretty sleepy, I would say. I don't know how else to put it. It doesn't sound like the 20th century American broadcaster TTS voice that you're hearing most typically. What did we learn when we started doing this? We learned a lot, right? Like, I think gone are the days when someone wants to put one Google TTS voice into production. How are they choosing that voice? They're choosing the one North American English voice that their customers hate the least, right? I think that's like a very poor status quo. Another thing that we've learned, right, is like latency is really important. I don't think people would be at this conference if people didn't understand that latency was really important for really human-sounding experiences. We found in the outbound calling case, for example, that for every 100 milliseconds of introduced call latency, API call latency, that the willingness to talk to the bot decreases by something like 10%. Like 10% of people are hanging up for every 100 millisecond increase in latency from the bot response. I think this is sort of underappreciated in 2025. It used to be the case that when you're building enterprise-grade text-to-speech, that there was an assumption that what you send to the API would be what the API returns in speech. You don't see that nowadays. I think like with a sort of focus on these LLM-driven approaches to speech synthesis, I mean, the same thing that applies to hallucination in the LLM, the text LLM case also applies to speech synthesis. So you're seeing, right, like models from companies that have raised hundreds of millions of dollars that are repeating the digits in a phone number, for example, or cannot pronounce a number of different brand names. And when they do pronounce them correctly, maybe they pronounce them 80% of the time, right? And like one thing that we learned is that if you're building fast food ordering for Taco Bell, it doesn't matter how fast the model is, how lifelike it is, if it can't pronounce gordita or chalupa. They actually really care about that, it turns out. I also think, like, I don't know if raise your hand if you know what SSML is. Okay, so like SSML was, literally I was 10 years old when this was formulated, but SSML stands for Speech Synthesis Markup Language. It used to be the case, right, that these systems, these text-speech systems, and this, by the way, is like happening again in 2025, right? Like Bell Labs builds TTS, so-and-so builds TTS, and they each have their own markup language for doing things like slowing the rate of speech, for adding a pause, for reading out something as a phone number, for reading out something as an address. And I think, someone can correct me if I'm wrong, I need to brush up on the history of text-to-speech, but like early 2000s, there was this XML structured markup language that unified all of those things. That remains a problem today, and indeed probably is way worse because of all the different architectural approaches that people have taken to building really high-quality speech synthesis models. And by the way, what comes at the cost of controllability of these systems is often, sad to say, their prosodic lifelikeness. I do think, right, like this stuff remains really important for enterprises, particularly on that pronunciation front, and is going to be a focus, I think, moving forward of many folks who are trying to unify some of the approaches that people are taking to speech synthesis today with the approaches that people are going to want to take in the next couple of years. How do we build models? We first started by building a recording studio in San Francisco, and then slowly but surely we've assembled one of the largest proprietary, there's a lot of caveats here, but I know this is true, given the caveats. We built the largest proprietary data set of studio quality conversational speech in English in the world. And we picked pretty purpose-built architectures that were different from some of the other early stage sort of innovative startups in the space. And what we were doing with design partners very early on is collecting, I would say, very genre-specific sets of speech. Right? So like the way that we talk when we're having a conversation with a friend is very different than the way we're talking when we're reading an audiobook, right? Or reading to one of our kids, or which is also very different, by the way, than like how an IVR system might sound. And so we've collected a lot of this data just to give you a sense, like, and I don't have an image for the audio, but 2 audio clips are going to play. The first is a conversational sample that's coming from our recording studio.
And story 2.
Oh, sorry. This is the narration one. Anyway, here's narration.
And story 2. There was once a young man named Michael who was a huge fan of basketball. He had been following his favorite team, the Golden State Warriors, since he was a child.
And maybe conversational play next. Let's see.
What I'm curious about with these large language models is if you take their generations, whether it's image or text, I want to see the most similar text in all of its training data.
Right, very different way of speaking. And very relevant, I think, for the end customer experience when they're hearing these voices. Right, the kind of customer service modality, the genre, is also very different, right? So like one thing that we do with our partners is collect a lot of very specific data. You can imagine, right, like some of these call flows that folks are building, even in the era of large language models, they're not like, sorry to say, but they're not rocket science, right? Like people, when you call, you want to say, hey, thanks for calling so-and-so. I'm an AI agent. Here are some things you can do, right? Like it's no longer the days where it's like, please listen carefully as the menu items may have changed. But at the same time, right, like customer support is not rocket science. And so we collected a lot of this data. We generate a bunch of synthetic call flows using our customers' actual architectures. And then we go back to our studio, collect that data, fine-tune the model. We have two families of models, and I encourage you to come up to me after and help me think about how to position both of these, because they are, at the end of the day, very different, and it's hard to, for me, I'm speaking very candidly, like, explain the differences. So, right, like, we have 2 families of models. The first is the MIST family of models. It's a non-autoregressive model. What that means, right, is like when a customer sends us text, right? It doesn't matter if it's a sentence, it doesn't matter if it's a paragraph. We generate the entire audio in parallel in under 100 milliseconds. We today have had a lot of success deploying these models on-prem. The reason for that, right, is like if you have to be a pretty software-focused BPO, but if you are a software-focused BPO and you have an existing commit on Amazon, on AWS, say, for GPUs, then we've had a lot of success saying, here's the images for these models. It's so computationally efficient that you're going to end up spending a quarter of what you are on AWS Poly, which is Amazon's TTS. And by the way, it's going to be 10 times better. In the single model, right, like there's a sort of ability to generate an infinite variability of voices, which is also really compelling for use cases, right? Like where we're often, just to give you a sense of the lay of the land, where we're often entering in these software-focused BPOs is not the IVR system. People are building, right, like if you have 15,000 human agents, people are building training simulations such that you're talking to Rime for 15 minutes every day, right, which is what we're finding is like reducing agent churn, is improving literally like customer support success for these agents. And so they're generating something like 40 different personalities of fictional customers using our voices, and then yeah, it's a role-playing simulation oftentimes. So I think that's something that goes unstated oftentimes when we're talking about AI. It's not about like, I don't know, how do I put this? You know, I saw a report that was said something like, there's going to be probably, right, like today, there's probably like $750 million in contact center spend, and 3% of that is software. Right, like how much of that will be software in 10 years? A lot more. And at the same time, right, like there will be always humans in the loop. And I think underappreciated is that like AI will be used to make those humans a lot more effective and happier in doing their jobs. Okay, another thing about MIST too is that it has controllable pronunciation, right? Like a dirty secret is that for some of these LLM-driven TTS systems, even if they say they do, it doesn't always work, right? These are more stochastic. The MIST family, I guess one way of putting it is that this is a deterministic TTS system, which isn't to say it doesn't sound natural. It's just to say that it is controllable. I have to admit, right, like we have another model which is based on an LLM backbone called Arcana, and it sounds incredible. We also deliver it on-prem. It also does things that I think most people would never have thought an AI voice system can do. At the same time, I wouldn't call it controllable today, and we're definitely looking forward to unifying our approaches to building these systems. I can imagine, so Arcana V2 ships next week, multilingual out of the box, bilingual Spanish, English, Japanese, code switching, etc. And at the same time, right, like we want to bring some of the controllability that's in our MIST family of models to Arcana. Because today, if someone comes to us and they say, I'm just going to be honest with you, if someone comes to us and says chalupa is pronounced correctly, we're going to be like, have you tried spelling it in a different way? It's pretty annoying. Again, this I would also describe as a fully end-to-end text-to-speech model, but again, it's auto-aggressively generating these speech tokens in the same way that an LLM would auto-aggressively generate text tokens. It also runs on-prem, but instead of on A10G GPUs or L4 GPUs, it's running on A100 GPUs and H100 GPUs and H200 GPUs and B200 GPUs, which are just insanely expensive today, something like $6 an hour per GPU. But it sounds incredible. I don't know what else to say. Arcana, very tarot-themed. Here's a tarot-focused LLM-generated transcription, just to give you a sense of like how prosodically rich Arcana sounds.
So upright, the tower is like, boom, shake the room. Chaos, sudden change, collapse of illusions. But upside down, the vibe shifts. When reversed, the tower still hints at disruption, but it's more internal or maybe delayed. Think resisting a necessary change, holding on to something that's already crumbling, or avoiding a shakeup that's honestly overdue. It's like you see the lightning coming, but you're hiding under a cardboard box, pretending it's fine.
It also does things like laugh.
LA.
And the kind of insane thing is that because these are based on pre-trained large language models, I would call this a beta feature, but you can do things like include between those angle brackets things like coughing and humming that were never seen during training, during the supervised fine-tuning, but can generate things like sighing, gasping, coughing, etc. Okay, is there a use case for this in an enterprise IVR system? I haven't seen anyone do this, but it is. I dare say it's very cool. And so, like, where does this take us in 2025? I mean, we had this thought. This is a Substack article we wrote kind of when we were in our nascent entrepreneurial journey. Like, what would it mean if, when you were on the BART platform, what you heard wasn't just George or Grace, but a different voice every single time, and that voice sounded like someone who could be reasonably from San Francisco, right? And I think this is kind of taking us into a future in which, like, when you call the IVR system, this is kind of foreshadowing the rest of my talk, right? Like, you're not just going to hear one voice every single time. You're going to hear a voice that you respond best to. What does it sound like today?
And my name is Grace. Just to let you know, there is a Richmond train that's about to arrive on platform number 2.
Hey, what's up? My name's George. Welcome to BART's audio service.
So again, it took us 900 years to go from myth to technology, and it took us another 30 years to get technology that vastly surpasses the capabilities of that original myth. And then the reasonable question is, what's coming next? I think I want to inject a sort of contrarian take, which is that it's going to take a lot. It's going to take a lot to get to 100%. I don't know if anyone has heard of the bitter lesson before in machine learning. I think there's this tendency of folks, and I include myself in this category, even as a machine learning practitioner, where there's a sort of, right, like betting against the end-to-end system, right, the model that can do everything. And by the way, I believe that, and at the same time, right, like, no one would have thought we would have gotten to this point. And so I try to remain healthy in my skepticism of the AI hype cycle, right? Like, here's why. We have a customer who's building back office healthcare, it's IVR, And they come to us, they're like, hey, we've tried Google, we've tried Amazon, we've tried Microsoft, we've tried 11 Labs. And by the way, 11 Labs can't pronounce prednisone. And also, by the way, we don't just need prednisone to be pronounced correctly, we need hydrochlorothiazide. Like, apparently this is resulting in unsuccessful phone calls for them that hydrochlorothiazide is mispronounced, and so is biogesic. And so I do think, right, like, here's one reason to bet against an end-to-end system, is that, imagine this, you collect all the speech data in the world, everything that exists, right? And then Eli Lilly comes out with a prescription next year that wasn't in that training data. And by the way, it's the top-selling prescription medication in the world. You got to retrain the model. I don't know what else to say. And so at Rime, we're really excited about building developer tooling that makes it really easy to solve what I would describe as first-mile problems, probably. But I think in this era of end-to-end hype, people are often thinking about as last-mile problems, which, I mean, that's great for Rime. I think it's not great for folks who are building these systems in an era when it's easier than ever to build them. Again, right, like, what is the future? It's not just like one IVR system for everyone. Like, we power a lot of fast food ordering today. Something like any Domino's phone system that has AI is powered by us. And so at the same time, right, like, imagine you're ordering soda in St. Louis. You're going to say soda, just like I do. I grew up in Southern California. But if you're in Seattle or you're in Missoula, you're going to say pop. Apparently, you're saying pop. And if you're in the South, you're saying Coke. And so I do think, right, like, this one-size-fits-all is on a practitioner level, isn't very, in reality, appealing to folks who are building these models. I also think, right, like, we've had a lot of success in fast food. The reason is pretty obvious. People really care about the quality of the voice in a revenue-generating channel. This is a sales channel, right? Like, it's not like you're calling in a Chase Bank. And there's been some published about the work that we've done with our design partners in this area. We can tell you, for example, that if you call a Wingstop in Atlanta and you hear an African-American English AI voice, that the likelihood of that call succeeding increases another 15%. I think there's very real work that can be done to build a system that is self-perpetuatingly more successful for each customer segment. And, right, like, when you call Verizon and you're 25 to 35 and female and from San Francisco and tech savvy, they know that about you, right? Like, I think our vision, and by the way, we don't see this a lot today, but our vision is one in which people aren't picking one AI voice, but allowing for a flywheel by which you can match the voice to the customer in order to drive call success. Are we there yet? No. But again, it took 900 years for us to get from a myth of a talking head created by magic that could answer yes/no questions to a world in which 90% of all Domino's phone orders are all fully automated. And by the way, people are saying thank you at the end of the order. So that's the extent of my talk. I'm not sure exactly, are there time for questions or?
Well, we're just running out of time.
There's a minute and a half left I can see on the, but that's it. Thank you so much. Really excited that I got to tell you about the work we're doing at Rime.
Thank you, Lily. I saw two hands, so we're going to take two questions. But Lily, you're also on the AI round table, right?
I am later.
So you're sticking around.
That's true.
Great. Okay, go ahead, David. Try again, David.
So you mentioned changing the accents and based on where people are. Do you have customers that are right now on the fly changing how they speak to customers based on how they detect how the customers are talking? So if all of a sudden I detect a southern accent where it's going to have the system automatically dynamically change, or is it just based on caller ID or where they know the customer is?
Today, it's much more naive than that. They're putting like 20 different voices in production and then just testing which one's better, like a very simple A/B test. In the same way, right, that like Google tested 40 different colors of blue for hyperlinks in order to maximize for call-through rate. They're just throwing everything at the wall and seeing what works. But I can imagine a future when that's more dynamic. But today, it's not dynamic whatsoever.
Thank you. Joseph, was that a hand as well?
Same question about code switching.
Same question.
I also have something to add to that we have that's unique to SignalWire. If you have a toll-free number on SignalWire, you get the JIP, so you know kind of regionally where the call is originating from as well. So you could use that data to match what you were talking about.
Yeah, in the case of fast food, right, like people, if someone's calling a Wingstop in Atlanta, it's pretty reasonable that the person who's calling is in Atlanta. But for more sophisticated, right, like if you're calling one phone number for Verizon, that kind of information is the kind of information that people would use to personalize.
Okay, let's keep things moving and
Awesome.
say one more big thank you to Lily.
Thanks so much, you guys.